good. So thank you very much for replying this one. Correct answer. So suppose Arav, if I will go and I am writing that is group number one. Okay, group number one. We are having the lithium, then sodium, potassium, rubidium, and we are having cesium. What is happening, Arav? The size increases. Yes, yeah, no. Size is increasing. Size increases. If the size increases, Arav, so second point, what is there? Attraction between, because distance increases. So we are writing attraction between. Hmm. Thank you. So nucleus and outer electron decreases. Outer electron decreases. अब outer electron decreases means less amount energy required, है ना? Less amount of less amount of energy required to remove electron. Less amount of energy required to remove electron. Yes or no? So less amount of energy required. That is what we can write. Ionization energy decreases down the group. Ionization energy decreases down the group. Can you understand? Okay, down the group. Now, can we go in the period? I think you understood this one in the school itself, na? Okay, tell me in the period, Arav. Tell me in the period. What is going to happen in the period? Mhm. Uh, can, thank you. Can I delete this one? Can I erase this one? Okay. Acha, Arav, that is what you are saying correctly. See the lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine is there. You are saying that is ionization energy means IE increases. Yes, no? You said like that increases. But this is not the correct order, Arav. Somewhere there is problem. This is increasing, but here is this order. Here is okay. Here is okay. But here in this case, this is this order. And then again this is like that. Okay, so two places are there is the problem is here. Two places. Sorry, this is erased. Two places there is the problem. This way. Now, Arav, what is the reason? Can you tell me the reason? Increases in bracket generally. Now, question will be asked to you. Why beryllium has beryllium has high IE than boron, even though even though unmoving even though unmoving left to right, you said only left to right, ie generally what is happening increases, ie generally increases. Now Aro, tell me the answer please. Hmm, it must be taught in the school, yes or no? That is why. Okay, not a problem, not a problem, because the in your exam that is MCQ also comes na objective. No. Okay, okay, okay. Acha, no problem. Okay. So what we are going to do, Arav, here, I am going to explain you. See, you let me know one topic. If atom is stable, if atom is stable is atom. So to remove electron, so if you want to remove electron, Arav, remove electron. So more energy required or less energy? More energy required or less energy? More energy required. More energy required. A more energy required, that is ionization energy will increase. More energy means ionization will be high. Yes or no? The second case, they are saying if atom is unstable. If atom is unstable, so that is, so to remove, easy to remove. Yes or no? Easy to remove. Easy to remove electron. Easy to remove electron. So So if it is easy to remove electron, more energy required or less energy? Less energy required. So here is less energy required. Less energy required. So less energy required means ionization energy will be IE, will be what, student? Will be less. Yes or no? Okay. So that is here the first cases what you wrote, difficult, है ना? Difficult to remove electron, है ना? Difficult to remove electron. Difficult to remove electron. That is what the point. Now Arav, come here in the previous page. So that here. Now lithium atomic number is 3. This is the 4, 5, 6, 7, 8 and 9. So now go for the beryllium. Beryllium is what is 4. So that is 1s2, 2s2. And boron, Arav, boron is 5. So what is 1s2, 2s2, 2p1, right? Above, I want to know, I want to know out of these two, which have the stable configuration. Out of these two, which have stable configuration? This or this? Beryllium. So this is stable, yes or no? Is stable? Is stable. So what will be difficult to remove electron? Difficult to remove electron, yes or no? Difficult. So more energy required. More energy required. So if more energy required, so IE will be, IE is high. Can you understand this one? Okay. And here is the, this is the unstable, Arav. Unstable. So unstable means what? Easy to remove electron. Easy to remove electron. Yes or no? Less energy required. Less energy required. If less energy required, so IE will be, IE is less. IE is less. Can you understand now? Okay. If you want to make a note, you can make. Otherwise, I will give you some other topic. Can I erase this one? Okay. Abaro, you explain for the nitrogen and oxygen. You explain for the nitrogen and oxygen. Uh, uh, but oxygen is less, na? You see, less than nitrogen. Uh, huh. So, can, huh, huh, hmm, hmm. You do this type of configuration, Aram. Is do this type of configuration, then you can reply now, dear. Huh. Hmm. 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 Done. Hmm. Nitrogen. Hmm. Hmm. Which why stable, Arav? Why it is stable? No. We are this one. What is the rule of stability? Half filled or full fill stable, na? Ha- So this is p orbital is 3 is na half filled, and this is what 4 is there. So half is 3, full is 6. So it is what is unstable. Why it is unstable, Arav? So it is neither half filled, neither half nor full. Getting my point? Yes or no? Okay. So this is all about the ionization. What other topic of the related to electronegativity they taught? Electronegativity. Any other topic? Please check. Please check. Hmm. Hmm. Okay. Uh-huh. Uh-huh. Acha, okay. Electron spectra and produce when photon are emitted from the atom as excited electron return to lower energy. Okay. The line emission spectrum hydrogen provide evidence for the existence of electron discrete energy level which cover at the higher energy. Description of relation between color, wavelength, frequency, and energy across the electromagnetic spectrum. Distinction between continuous and line spectrum. Description of the emission spectrum, hydrogen atom, and what is there? Relationship between the line and energy transmission to the first, second, and third energy level. Relationship between the line energy. Okay. Okay, Arav. This is only the topic they taught till now. But only one Acha, entire document. Wait, Arav. Let me download this one. Acha, it is 10 MB. Okay. But the basically ideas to be covered. Let it get download, na? Hmm. So, are you enjoying in the school? Everything you are understanding? Uh-huh. Okay. Means chemistry you are facing little bit problem. Yes, na? Chemistry you are facing the problem. Yes, na? Okay. Just it is getting downloaded. Seeing the topic. So previous class is not helpful. Whatever till now we studied. Yes, Yaro. Till now we study during summer. Okay. So Rutherford, see, you have given so many. So Rutherford is all you understood these things I taught. Atomic number, how subatomic particle. These all things we have studied. Electronic configuration we studied. Okay. So where is the spectra? Uh, Average atomic mass we have covered. So that is, I think, that is mass spectroscopy we did not cover. This is one. Radioactivity not covered. That is second. Okay, spectrophotometer. Okay, this one. Main is this one. Okay. Uh, Line spectrum. This we did not study. Okay, this one is the. Okay. Okay, understood, Ara. But here the energy level, this is are also there. So this atomic structure is fully completed in the school. The atomic structure, the chapter is completed in the school. Okay, so that is above rule and these all things completed. Okay. Okay, not a problem. So we are going to start the put down heading emission spectrum. Emission. Emission spectrum. Put down heading emission spectrum. Can you give little bit idea about the emission spectrum? Any idea? Any idea? No idea. Any idea about the spectrum? Uh-huh. Hmm. What is spectrum, Aro? Don't know, na? Not a problem, not a problem. Uh-huh. Yes, 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 correct. So if you are talking about the spectrum, na, spectrum, okay. So uh, spectrum means the band of lines, you know, bands of line, bands of line. A best example, you see, example, best example, na. If I will go best example, so rainbow, Rainbow, rainbow. So rainbow is what having that is so many colors are there. Yes, yeah, no. Okay. So that is what that is the type of the spectrum. Okay. But in the atomic structure that we are not going for that one, that rainbow type, that is because of the diffraction or refraction of light. But here, if you're talking about the emission spectrum, so I am writing the line when electrons from high energy orbit, high energy orbit, when electron from high energy orbit falls to high energy orbit falls to low energy orbit falls to low energy orbit, then it lose energy. Then what? It lose energy in the form of radiation. Lose energy in the form of radiation, in the form of radiation. These radiation are these radiation when arranged. These radiation when arranged on the on the basis of wavelength. Okay, wavelength. Then they are they are termed as what they are going to termed are. They are termed as spectrum. They are termed as spectrum. Termed as spectrum. This is what the point. If you can guess out. Again, I am telling you, Aro, the meaning of this. That is, let us try to understand diagrammatic way. This is what is the Aro. Suppose, huh, okay, okay, okay. You can write this one. Hmm. Done? Slowly, slowly. No need to be very hurry. Okay. Now, Arav, let me draw the diagram. Let us go with the diagram. How the in your syllabus this is the they have given the hydrogen image example. They have given hydrogen emission spectrum. Hydrogen, it will be very much easy, you know, by the time it will be very the easy. Hydrogen emission spectrum, right? Hydrogen emission spectrum. Ara, what we are going to do, just you try to understand here. We have filled out the gas. Okay, we have the filled out the gas here. Okay, this is the gas is there. Now if you talk about this gas, so what gas we are taking? Hydrogen, H2 gas. This is the H2 gas. H2 gas. Now you are passing the electricity. You are passing the electricity between them. You are passing the electricity between them. Okay. So here electricity. So hydrogen. means, so that is what is happening. H2 is getting break into H2 gas is breaking to, that is 2H plus, hydrogen gas. Okay. Of this hydrogen gas, what is going to happen? Firstly, this is the hydrogen, atom. This is the atomic form. Alone means atom. Now, keep in mind, now hydrogen atom, what they are going to do are absorb energy. This is the absorb energy. Absorb energy. So if it is absorbing the energy, it will what? Electron will be out. That is just like ionization energy. Yes, yeah, no. If hydrogen atom absorb energy, so electron will be out. Yes, yeah, no. See, in this discharge tube, what is this one is discharge tube. DISCHAR. Discharge tube where we pass the electricity, like we study cathode ray. So in this discharge tube, what gas we have filled? H2 gas. So firstly, this H2 gas, H bond H is there, na? H bond H is there. So if the bond get break, it form the 2H. Okay, this is the gas. Now the just now we study na ionization energy. That is where we study ionization energy. That is removal of electron from the atom. So if you absorb the energy, this atom absorb the energy, electron will be coming out. Yes, yeah, no. Now, Arav, now see the one more page I am going here. The hydrogen atom is there. These are this one. So this one you already studied, that when electron absorb energy, right? This is the energy. When electron absorb energy, radiation, any type of energy, so it will jump to the higher energy orbit. That you study now. अब now jump for 10 की power, for 10 power minus 6 to 10 power minus 8 second, this many second, this is going to jump for this many second. When energy absorb, right? Now Arav, this is going to, when electron going to be lose energy, suppose hydrogen is there, now it is going to be losing the energy. Arav, suppose here is electron is there, so when electron losing energy and falling here, so what will be happening? Loss of energy will be there now. Yes, yeah, no. Yes. So because this is there for the very small second, then here is the electron fall. You know, electron fall. Here is electron. That is what we are writing. Electron falls. So electron falls to lower orbit. So it will be the loss of energy. Loss of energy. Yes, yeah, no. Huh. This loss of energy is in the form of radiation. Every light is in the form of radiation. Getting? So this radiation, you can say the group of radiation. If you see na group of radiation, this is what is known as what? Spectrum. Since it is loss of energy means that is emission. Emission means loss of energy. So this is going to be emission spectrum. Now come back to first page. Now come back here. Now electrolysis you are doing, supply the energy. So what will happen here are, firstly H2 gas. Keep in mind, very slowly I am trying to make the definition clear. So H2 convert into hydrogen. Then hydrogen, from the hydrogen electron is coming out. This electron is in the form of what? Energy, है ना? This electron means that is so that is what will happen. This radiation, loss of energy, this is the loss of energy. How we are passing the loss of energy? Where we are passing to the that is we are passing firstly to the slit. This is called slit. Slit means what are of slit? If you are talking about slit, so slit means, slit if you are talking about this slit, that is the which allows certain light, one single radiation this is allowing, right? Now getting my point. Slit means that is few portion is splitted. Now this radiation one is passing. Okay. Now you pass this radiation on the prism. This is the prism. Okay. Passing to the what arrow, that is the prism. Have you ever studied about that is refraction or scattering of light? Okay, very good. So, yeah. So now we are taking is Arab this one on the what is this is the screen, right? This is screen. Okay, on this screen, what will happen, Arab? This is the getting split out. So this is diffracted here. One ray is diffracted here. This is diffracted here. This is diffracted here. So the white light or any one radiation is split into the several. Yes, yeah, no. That is what the no splitting of light is known as what refraction. Okay, refraction. So this is what is or whatever you are finding now. This is what is emission spectrum. Emission spectrum. So it will be almost. That we are going. Yeah. We are going. We are going. We are going. Till now the definition. Till now I explained the definition. Hmm. Can I remove this one? Hmm. Okay. Now, if you see this one, whatever the line you are seeing, that is, if you see this one band, if you see in a band, so how the band you are going to screen on in the screen, what you will find on the screen, you will find that is some that is black color. You will find the some black color will come. So many black no band will be there. So many the light blend will be there, right? So black. This is what this all the bands whatever you are observing. When the light is falling, na light. So that is what that is the white color will find. But other are that is when the light is not falling, there will be gap, na. So what will be there, Adam? That will be the no radiation is there. No, all the places radiation is not there. So some band you will get. Okay, in the screen, what is in the spectrum? This is what is the some band will be there. Everywhere will not be the light colorful. It will not be there. So some are suppose this one is there. That is what is going to be dark band. Dark band means where no radiation is there. And then here the gap are there. That is what is called bright band. Bright. Here the bright band. Some color will come band, bright band. So here color will come. As a whole, this emission spectrum is known as what? Line spectrum. This is what is all is known as line spectrum because it is these all are arranged in the line. So that is why it is known as what? Line spectrum. And this one is, if I will say this one, what is the screen? This is the photographic plate. Photographic plate where you will see this all the record photographic plate. You are going to record on the photographic plate. Okay. Now these are the you understood, no? In the line spectrum, so many lines are there. Can you see black line, white line, dark means dark line and bright line? So many are there. So many dark are there. So many brights are there. Right. So now what the point you have said that we are going to explain. Now come for this one. Come for this structure. Ara, what is happening here? You see dear, that is this structure is the absorption. This is the absorption for absorption. But we are not going for absorption. We are going for the emission. Emission means loss of energy. Emission. Now, this is the diagram required to you to understand. Now let us see. In line spectrum, one line I'm writing in line spectrum, in line or in lines of, you line the difference way. In lines of, wait. Statement is not, I need to make the statement correct. The lines in, the lines in the emission spectrum, you know, emission spectrum, emission spectrum. Okay. The lines in emission spectrum of hydrogen. Hello, Arav. Sorry, na it was get disconnected. Actually, na after every 40 minutes, na it is very difficult what to do. Okay, not a problem. Wait a moment. Let me join. One second, Arav. Let me share the screen first. I need to share the screen. Oh, no, it's not getting shared. Let me. Yes. Now God become the host. Now. Yes. Okay. Now, Arav, what I was explaining all gone, but let us try to understand. Again, I am going little bit. So that is what they are saying. Emission spectrum is having so many line. Emission spectrum. So that is what are the line name is there? Band are there, dark band and the bright band are there in the emission spectrum. Okay. The that is colorful. Every radiation is colorful. Some in the visible region. That is when the white light you see now. White light is there. White light. है ना? So white light in the visible region is split into seven color. Yes, yeah, no. So they are talking about this one. Okay. So that is emission. They are saying in emission spectrum, the lines in emission spectrum are classified as emission spectrum are classified as how they are classified as. Okay, so there are five types are there. That is what you are saying, n equal to something you are saying na. So let me explain you first. Okay, so firstly you try to understand diagrammatic way, then we will write the in the descriptive way. So hydrogen, this is nucleus. Here we are going the first orbit, then we are going second orbit, then we are going third. Here is the fourth one, this is fifth one, here is sixth one, and the last one we are going for the seventh one. This is what the we are going for this one. Now Ara, the yeah. Yeah. KLM1. This all are. So Ara, in the emission, electron get fall. In the emission, electron get fall from high energy orbit to low energy orbit. Okay. So Ara, if the electron is just falling to the ground state, if the electron is falling to the ground state, so high state to the ground state, high state to the ground state. So high state, if the orbit number you are counting, so this is the one number, here is 2, this is 3, here is 4, this is 5, this is 6, this is 7. So if it is falling for the 7 to 1, or it is going to be 6 to 1, or it is going to be 5 to 1, or it is going to be 4-3-1, 3 to 1, and here is 2-1. Okay, so these all the series if you are obtaining now. Okay, so this series is known as Lyman series, Lymon. This is called Lyman series, है ना? Lyman series. Lyman series means electron falls from, है ना? Electron falls from where, Arab? Can you tell me? High energy orbit to high energy orbit to ground state. Orbit to ground state. This is what the concept ground state. Electron fall from high energy orbit to ground state. Means N2 and N1. N2 means what, Arab? N2 means high energy orbit. High energy. High energy. And N1 is low energy orbit. Now tell me, if it is the ground state or no ground state, so ground state will always be one. It always be one. But if you are going high state, can you guess me from where they can be fall down? And it can be from the 7 or the 6, anything. 7 to 1 it can jump, or it can jump from 6 to 1. Yes, yeah, no. Or it can jump 5 to 1, or it can jump 4 to 1, or it can jump 3 to 1, right? Or it can jump, that is 2 to 1, or it can jump that much is possible, 2 to 1. So these all the cases are explaining what series are a Lyman series. This is what is known as Lyman. There is so many numerical are there. I need to uh, get to know how much depth we need to go. Okay. So the Redberg equation they taught are a Redberg equation, Redberg constant, anything like that? No. Huh. Okay, okay. Here infinity is also possible. Infinity to 1 also possible. Okay, that rightly you said. It is also, no. Infinity means anything it can be. N number of orbit is possible. According to Bohr's atomic model, n number of orbits is possible around the nucleus. So one series you got to know, Arav. Can I erase? Okay. In the same diagram, or of same diagram, if see keep in mind, if the electron jump from first orbit to high orbit to second orbit, है ना, high energy orbit to second orbit, not the first orbit, high energy orbit to second orbit. So this is what is called is today are a Balmer series. Balmer series. Balmer series. Balmer series means the visible region. This is the only series which comes in the visible region. Getting? All our others are the radio region or ultraviolet region or infrared region. This is the Balmer series is the visible region. Now here huh, so n1 is equal to 2. N1 equal to 2. But n2 is equal to, it may be anything more than 2. Let me write. Let me. Balmer series, na? Balmer series. Balmer series. Balmer series. It is it is invisible region. This is only invisible region. Visible region. It is only invisible. That can we see the color we can see. Okay. Now what they are saying, where 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 electrons from, what they are saying, electrons from high energy orbit, high energy orbit jumps to energy orbit, jumps to what are energy orbits, jump to what are second orbit, yes or no? So that is N2 and N1. N2 and N1. So N2 means high orbit, high energy orbit, and this is the low. So low means this is the fix, 2, 2, 2, 2 fix. So first one can be possible infinite to 2, then it is possible 7 to 2, or it is possible 6 to 2, or it is possible 5 to 2, 4 to, that is 2, or 3 to 2. This is also possible 3 to 2. So electron can jump this way. Getting? This is the value of the n na. So this is the this what. So high energy are high energy, they are the falling na, electron is falling, emission means loss of energy. So when electron jump from high energy to low energy, so there will be loss of energy, then it will fall na. Yes. N2 means high energy orbit, N2 means high energy orbit. uh, uh, correct, correct, you can say. See, N2 can be, N2 means high energy orbit, high energy orbit, high energy orbit. It can be, what is the order? So order is K, then L, then M, then N, then O, then it can be infinite. N1 means low energy orbit, low energy orbit, low energy orbit, low energy orbit. In case of emission, N1 should be always lower than N2. है ना, in case of emission, because loss of energy when it will be, when the electron from high energy orbit to jump to low energy orbit, then one will loss na. So this what you point you are raising now. So N2 point you are raising. So N2 it can be, that is N2 it can be 7. Okay, N2 can be 7. Here N2 means 7. So N1 will be always 2 only in case of Balmer series. N2 can be 6, but N1 will be always 2. N2 can be 5, but N1 can be again 2. N2 can be 4, but N1 can be 2. N2 can be how much? 3, but N1 can be 2. Yeah, N2 can be infinite, but N1 can be 2. Now is it clear to you? Okay. Conversion limits is the numerical. When you are going to calculate the energy, when see the previous one. Okay, conversion limit means that is when electron is falling na, when electron is falling, so how much energy is released when electron is falling. See, the here is the hydrogen, and when electron is falling to here, so that is conversion means how much energy release, how much energy release. Here conversion can be used, energy release. No, released. No other conversion released. So this energy we have to calculate, wavelength we have to calculate, है ना? Because this is coming out in the form of wave, na. So what is the wavelength that we need to calculate? What is wave number we have to calculate? What is speed we have to calculate? Speed means the speed of light only. So there will be conversion, no other conversion. Where is the conversion? You go in the PDF. Can you show me the conversion? There is no conversion. Conversion means I am not getting what you are saying. Conversion will be maybe the picometer to meter. It can be the wavelength. The conversion can be there now. I will see. I'll see you. I will see your slide now. Then I will tell. Hmm. You tell me page number. Page number. You tell me where's the conversion limit. Okay, please. Wait. Till now I didn't go. Huh. So in 69 you are saying they are saying hydrogen atom emission spectrum, this one. An atom is the most stable when the electron is in the lowest energy ground state, that one you are talking. So where is the conversion? There is no conversion. Huh. Oh my god, see the diagram what I am making now, the diagram which I am making, this one, to make it clear to you. See the diagram how it is given. Can I erase this one, these lines can I erase? Okay. Okay, wait. I am telling you, it's not difficult. You 100% you will be able to understand. Let me read. Avaro, here you see in the conversion limit what the word you are using. Most probably you are talking about that only. What I guess. See, Aro, here the top line in the your picture, the top 69. Huh. Top line you see, top line at the very top. So at the very top, what are there? Infinite is there. Yes, yeah, no. Infinite. So infinite means the above 7 in the diagram here, above 7, this is the seventh orbit. Above seventh, what is there? Infinite will be there, infinite orbit, getting? Okay. After 7, they did not start 7. Actually, they started from infinite. So 7 you left out. Just you count out from the 7. Okay. Very carefully you see. This line what is explaining now. That is the last line. This is the infinite line. Here the electron is present. Suppose the infinite. So what is happening? What is happening? So there are so many lines are there. Now come back to the line. 1, 2, 3, 4, 5, 6, whatever the so many lines are there here. Then finally it is here at the bottom, it can be the one. I drawn so many lines. So here is the n2 is equal to, it is 1. N1, not n2. Here is the first line. You better you understand. This is the first orbit. Here is you can go, that is second orbit, right? And something you can remove out because it will be the more not required. Okay, here also it is not required. So here is 1, 3, 4, 5, 6. Okay, so these many lines are there. These many lines. The first line you see are a first line from where the electron is falling. Keep, keep eyes on that. So that is first line. Second to the ground state is there, dark line, and there is mentioned that is UV region. Okay, then third to first. Then what they have said, 4 to first, then 5 to first, then 6 to first they have given, and that infinite one they did not give. Infinite one they did not give. But these all the lines, what they are saying, Lyman series. Lyman series. Yes or no? So the higher one is na N2. Higher one are the N2, but they have mentioned N, that is okay. So higher. So similarly, this is what this diagram what I made, circular one, and this one. That is both are the same. Both are the same. Now the second line you go. Second one for the Balmer series. What the Balmer series they are talking about? That is high energy orbit 2. They are jumping to second orbit. So from this one to here, okay, from here they are jumping like that one, then after that it will fall from the, not this one, actually this is going to be the this orbit, then from here, or wait, okay. So how it is jumping means the 6 2, they are jumping from the 6 to 2, 6 to 2. So let us try to draw the ascending order. So 6 to 2 means this will be the first one, then this one, then this one, then this one, and then maybe the some other are there. So it may be also. So this is what they are saying, that is Balmer series. Balmer series. And Balmer series, I told you, visible region. What we can see in the our eye, visible region. And visible region, these lines are made in the colorful. You can see. Other are all are dark because the first one is UV, then Balmer. Other are the, that is other series are in the which series? This is infrared that you cannot see by naked eyes. Now see the another one, Paston series. Paston series, if you are going around Paston series, so how these are arranged? That is third orbit. They are going to fall into the third orbit. So that is these series are what is going to be Paston. Paschen. Now is it clear to you? This diagram is clear to you? So both diagram na identical. Both diagram are the same. Okay. Both diagram explain the same. Hmm. Lowest level determine the name of series. So the first point they are saying ground state. Ground state means n is equal to, ground means what are of? Ground means the lowest energy state. So n1 is equal to one state. The first is the ground state. This one. This is the ground state. Getting my point? So see, so in your syllabus, so many lines they did not mention. Some line they mention, some line they did not mention, but they may ask this one. Surely they will ask. So can I go? So, two series we taught. Third series can I taught is student Arab, that is Paston series. Paston series. Can I tell you Paston series? Uh, it is it is in infrared. INF infrared. It is in infrared. In which infrared region means you cannot see in the naked eyes. So it is infrared region. Okay, region. And and they these lines and these line are formed formed when, you can see the diagram and tell me, when electron falls from, where is Arav? When electron falls from what orbit to what orbit, Arav? Infinity. Thank you. High energy orbit. Infinity. Okay. High energy orbit. Okay. Infinity correct only. High energy orbit to orbit number third. Orbit. Third orbit. We can write that is third orbit. Third orbit. Getting this one to third orbit. Now, let me write. So N2. N2 means that is, you said the high energy orbit. High energy orbit. Okay. Where it is falling? N1. No, falling orbit. Falling orbit means lower energy orbit. Yes or no? Lower energy orbit. So lower energy orbit. So see, you are saying infinity to 3 possible, 7 to 3 possible, 6 to 3, 5 to 3, and then it will be 4 to 3. So these are all the series you are obtaining, no? Paschen, PASCHEN, Paschen series. Can you understand this one? Okay. Can I erase this one? You wrote, na? Okay. Next one is the bracket series. BRACKET, bracket series. Bracket series means this is, all are now the infrared only. IR region, infrared region. Now they are saying, so that is these lines obtained when, these line obtained when electron falls from high energy orbit to, where are high energy orbit to which orbit? Orbit to which orbit? First, second, third, fourth. What? Third is the past and fourth, fourth orbit. Okay. Then it will observe. See, infrared. So see, here is the one. This was the two. This was the one. Now this is the third one is the arrow. Third one. Here the electron, if it is falling like that, this one you can draw it. This is the Paston, PASCHEN, Paston. Now we are going for the bracket means this is falling to fourth. So from the high energy orbit to, they are going this one. So that is what is bracket. Bracket. Understood? Are you getting? uh, Paston means that is, they are falling to the third orbit, falling to the third orbit. Energy gap is more. Hmm. Hmm. It is in the infrared. Different. That is, the frequency is different. In the infrared, there are the range of frequencies are there. Range of frequency. If you don't mind, I will tell you the range of frequency infrared. Wait, I am searching out here now. Whatever these are there now, infrared is having so much range. Infrared is having so much range. So in that range, some are classified up to, here is the, that is the far infrared. One is the close infrared. Infrared means infrared are classified into 3 4 categories. You see, IR you are talking about now. So you are saying why? So that is, one is the far infrared, but this much is not there in your syllabus. Far infrared. Far infrared is Passon. Okay, Passon. Then one is the near infrared. Near infrared is called P fund. And last one is infrared. Okay, so infrared is having the 3 categories. That is far infrared, very long distance. Then infrared, medium, and there's near infrared, that is close one. Getting my point? So infrared are classified into the 3 categories. I'll share you the notes. I'll see my notes here. Then I will share you. Now is it okay? Infrared, your doubt. So, If you are going for bracket series, or let me bracket. So if you are asking bracket means if you are having bracket, so N2 and N1. Can you tell me? N1 is the 4. N1 is always going to be 4. What can be the N2, Arav? Infinite can be possible or not? Possible, na? So this is the what is, these lines are indicating what? Bracket. BRACKET. Can I erase this one? Uh, they will not give more away from these notes, whatever you say, or they can get the problem from out of the this one, from outside also. Page number you can go. Page number 65. Can you see, Arab? Page number 65. Uh, so in the 65, see, N1 is what, that is one they wrote now. They have this is only for Lyman series. This 65 now only for Lyman series. Don't get confused. This is only for the Lyman series. Balmer series is there, means N1 will be 2 and other will be what? That is the, but here they did not mention N1, N2, N3. Here is the incomplete diagram. Okay, this is the incomplete, not fully completed. So bracket, let me go for the P fund. No, P fund. Last series is what is called P fund series. P fund series. So P fund series, this is microwave is the UV rays, ultraviolet. Okay, microwaves are they don't come in the infrared. Radio comes in the infrared. I'll share you the range, Arab. It is all not memorized. It is not all memorized. If I will say, you will be confused. I'll share you with, and after just the soon after the class, I will share you the range of this spectrum line. Okay. Hello. Huh. So P fund series. This is also found in this is also found in infrared. Infrared. Okay. IR. Okay. This is what the point. Okay. This series, they are saying this series is obtained when, this series is obtained when electron falls from where? Electron falls from high energy orbit to high energy orbit to fifth orbit. Fifth orbit. High energy orbit to fifth orbit. So it is going to be what? That is P fund series. P fund series. So uh, N2 I am writing, and here I am writing N1. So N2, N1 is the 5 5. Every time it is book 5. And N2 it can be infinite, it can be 7, it can be 6. This much it is possible. So either electron can fall from infinite to fifth orbit, or 7 to fifth orbit, or 6 to fifth orbit. That is what is called P fund series. P fund series. Conversion and all, I will say, here is the problem. Firstly, let me check that is how much deep it is there, you know, how much deeply it is mentioned in your syllabus. So this is all about the hydrogen spectrum, Arav. Arav, you open the page number 71. Can you please read out the question, Arav? Read out the question number there. Hmm. Tell me, Arav. Uh, Balmer series, na? Balmer series. So that is B. Correct, correct. Very good, very good. So that you understood. Flame test, this is also there, that all I will teach. Any other question? Evidence. Explain the formation of lines, indicate the presence. Here that is in the page number 75. page number 75. Right, Arav? Page number. Evidence for the existence of energy level in the atom is provided by line spectrum. State how a line spectrum differ from the continuous spectrum. Right. Arav, continuous in the continuous spectrum now there will be the no band, dark band and band you will not find. Continuous spectrum. Continuous spectrum means it keep on falling. So this is not found in the atom. So continuous spectrum there is no band. There is no band. But in the line spectrum, what you got? Dark band and bright band. Got it? One more question. This is understood. B number. On the diagram below, draw four lines in visible line spectrum of hydrogen. Visible line spectrum of hydrogen. So visible, what is there? Ara? Visible means the Balmer series. Visible means Balmer series. So Balmer series means, Ara, it can be the on the diagram below, draw four lines in the visible region spectrum of hydrogen. So they are asking what are the four lines will be there. So first line will be first line if you are going now. So that is the uh, uh, third to second, third to second. That is first line. Then what will be there around four to second. So it can be second line, fifth to second, third line, and sixth to second. That is the fourth line. Yes, yeah, no. Okay, this. Explain how the formation of line indicate the presence of energy level. Explain how the formation of line indicates the presence of energy level. So when the electron falls from the high energy orbit to low energy orbit, electron falls from low energy orbit to high energy orbit, then it loses the energy in the form of radiation. So this will be the answer. Their answer also I think mention or what? Question number 15. They have mentioned or what answers? Answer are not mentioned, Nara, or answer they did not give. Okay, I'll see the answers, Ara. These are very easy problem. You can go with that. Most of the things I covered already in this chapter. Most of the things like see periodic properties I taught. Then ionization energy also we saw, atomic number that we have covered, orbital we have covered, above rule we have covered, stability rule we have covered. If you go down now, you will find that is most of the things we have covered. Next class what you want, or which topic you want, I will discuss. You tell me which topic. This is spectrum, little bit I will give little bit problem on it. We'll solve the problem on the energy. But other than the spectrum, you tell me which topic. Okay, but you please put a message. Okay. Uh, s- uh, Otherwise, your mom will say, "Na, sir, you are taking classes. My son is not understanding what you are teaching." Like that, she will tell. So, so next topic, na. Whenever you get the free time, you just put me message. I'll teach you. If you not tell, I will teach you mass spectrometry. I will teach you that topic. Okay. Huh. So for today, I am going out now, going for the lunch. So we'll teach you in the next class. Okay. Okay. Bye, Aro. Bye. Take care.